And the intent of this video is just to give you some help if you're a user of a TI Nspire calculator of how to use it to find quadratic roots as well as the vertex on a parabola or a quadratic graph. And again, it's just a calculator orientation just to help you a little bit to shortcut the process. Also showing you a little bit of the limitation of the polyroots feature as far as finding roots. The first thing we want to realize is we want to find roots for the equation at the top of the screen. Then we'll go on and find the vertex of a couple of equations at the bottom of the screen. So for the top of the screen, 3x squared plus 8 equals x. Remember that if we're going to use quadratic formula, or even the calculator to do this, we first need to be equal to 0. So we can first say that 3x squared minus x, let's bring that x over to this side, plus 8 equals 0. But now we can identify that a equals 3, b equals -1, and c equals 8 for our quadratic formula. Now doing this by hand, remember we would set up that x equals -b, so +1, plus or minus the square root of b squared minus 4ac, which unfortunately means we have to type in -1 squared minus 4 times a times c, and that's a lot of typing, divided by 2a, so divided by 3 times 2 on the bottom. Even if we simplify that down a little bit, we're still going to end up typing in more than likely the whole discriminant. 1 minus 32 times 3 would be 96, and so 1 minus 96 would be a -95 over 6. And so we're going to have some imaginary answers. It's going to be not very clean, which means rounded answer is probably going to be the best way to go, which we can take advantage of again on our calculator. Now, one way to do that would be type it in all yourself since we already had it set up, but the calculator also has what's called polyroots. So if you go to algebra, under the menu number 3, you can go to find polynomial tools, again number 3, and number 1 is find roots of a polynomial. Now if you know they're real, you could always use number 2, or if you know they're complex, you could use number 3, but I would just use number 1 most of the time. Realize we're working with quadratic, so our degree, remember our highest exponent, is a 2. Our roots, since we probably aren't sure one way or the other, although we already saw the -95, we want to definitely be complex. Real answers aren't going to work for us this time. Go ahead and hit OK. And now all we have to do is enter in our A, our B, and our C. Now you'll notice that on your formula it calls it A sub 2, A sub 1, A sub 0. But recognize the formula A, B, C. So looking at our three numbers again, 3, -1, and 8, we're just going to type in 3, -1, 8, and then go ahead and hit OK. Remember to use tab to go between the boxes. Now it's going to show us that we typed it up correctly, 3x squared minus x plus 8. We're trying to solve for x, and if you hit enter, you'll get your two imaginary answers. Now 1/6, you'll notice, is a perfectly good number, but your other number was more than likely an irrational number, which means the best you're going to get is a rounded 3-decimal number, or more decimals if you want them. But you will notice the I here, and if you arrow to the right, oh, looks like it doesn't want to let me there, but if we arrow off to the right, you'll notice the other I in this part. So 1/6 plus or minus 1.624 will be about the best answer we're going to get. So 1/6 plus or minus 1.624 I. There are our two rounded solutions. Rounded off on the right there. If you want them to stay exact, you're going to have to do the work yourself, unfortunately. So that's just the best we're going to get, which we can take a look and say, well, hey, 95 would break down with a 5, be a 1 and 9, so 19. That's really not going to go anywhere. So actually the best exact answers you are going to receive are 1 plus or minus the square root of 95. Don't forget that we're going to pull out that I out in front of there. And I'm going to leave myself a little more room there. So we do want to pull out that negative at least and call it I root 95 all over 6. And again, there's your 1/6 on the left, and root 95 over 6 would be that 1.624. Again, a little bit of a limitation via the calculator only because it's always going to give you that decimal solution. If you want the exact, you're probably just going to have to do the work yourself. Now, also on the calculator, though, we can find a vertex. Now, you'll notice that the equation on the left is in vertex form already. So we should already know that 1742 should be our vertex. which also means there's fairly large numbers. But if we go to our calculator real quick, I opened up a graphing screen, and I've already pre-typed it in there, but if you press Control G on our calculator here, you'll see that equation number 1, oops, I forgot my negative, there we go, is negative 3 x minus 17 quantity squared plus 42. I'm going to go ahead and hit enter. Realize we're probably not going to see anything, so I'm going to squish this down a little bit, just grabbing the axis and pushing toward the origin so that we can see, hopefully, at some point, our graph there, because it's a fairly large graph. Remember, 1742 is our vertex. If we want to find that vertex, though, a great way to do it is to go ahead and press Menu, Analyze Graph, and you can find the maximum. And it's similar to finding zeros on a graph or intersection points. Finding a maximum, we just need to create a left bound and a right bound. So I'm going to go left of my vertex, clicking. Notice I'm going to shade all that in and then click to the right, and you'll notice I've already got the point 1742 right there. But if I click, it'll be nice and bold, and I can write down what my vertex is. Now, doing that same thing with our third equation, you'll notice that I press Control G again. I'm going to go back to function number 2. We've got 3x squared minus x plus 8. If we go ahead and hit enter again, it should be on our screen. And then we just need to squish our axis down again, because again, it just happens to not appear directly on there. Now, it might look a lot like 0, what is that, 8, according to our numbers, but it also looks a little bit off to the right, so we better double check that. Let's go ahead and press Menu, Analyze Graph, minimum this time, because it's the bottom of our parabola, but left bound, right bound, and you'll notice 0.166 or 0.167, probably rounded to 3 decimal places, 7.917. So 0.167, 7.917. And that will be accurate to 3 decimal places where our vertex will be. I hope that helps you using your calculator, using it to find minimums, maximums, or finding roots of polynomials, essentially quadratics. Good luck and have fun.